Hi, hello everyone. Myself Chandan, working in Tumkur University. In this video, I discuss on fundamental theorem of algebra. The statement of fundamental theorem of algebra is every polynomial equation f of z is equal to a0 plus a1 into z plus a2 into z square plus 1 an into z power n is equal to 0, where n greater than or equal to 1 and an not equal to 0 has at least one root. In fact, it has exactly n roots, where a0, a1, so on up to an may be real or complex coefficients. Let me know the proof of this theorem. Suppose given f of z is a polynomial, which is nothing but, since it's a polynomial function which is analytic everywhere in a complex plane, that is f of z is analytic for all z. To prove this theorem, I use contradiction method. By using contradiction method, I want to prove this theorem. Conversely, suppose contrarily, suppose f of z not equal to 0 for all z. Suppose if f of z is equal to 0 for at least one value of z, then we can conclude that f of z is equal to 0 as at least one root. Suppose contrarily, f of z not equal to 0 for all value of z. For all value of z mean f of z not equal to 0 in entire complex plane. Then let us consider another function g of z, which is equal to 1 by f of z. Since f of z is analytic everywhere and g of z is equal to 1 by and f of z not equal to 0, hence g of z is also analytic. Hence g of z is analytic for all z, which is nothing but g of z is analytic everywhere in a complex plane. So g of z is analytic and n is greater than or equal to 0, an not equal to 0. Which implies that g of z is analytic everywhere. G of z is analytic everywhere in the complex plane. G of z is analytic everywhere in the complex plane. And g of z is equal to 1 by f of z as z tends to infinity, f of z also tends to infinity, since it is a polynomial function. Hence g of z tends to 0 as z tends to infinity, which is nothing but g of z is bounded. G of z is bounded. Bounded definition of bounded function is, if there exists a positive number m such that modulus of g of z less than or equal to that number. Since g of z tends to 0, z tends to infinity, hence g of z is bounded. By Liouville, with the theorem of Liouville theorem, if f of z be analytic and bounded in the entire complex plane, given here also g of z is analytic for all z, g of z is analytic everywhere in the complex plane, and g of z is bounded. F of z is any function which is analytic and bounded in the entire complex plane, then that function is constant. That is, the only function which is analytic and bounded in the entire complex plane here are constant functions. So here g of z is bounded, here g of z is analytic everywhere. G of z is analytic everywhere in a complex plane, and g of z is bounded. G of z is analytic and g of z is also bounded, which implies that g of z is constant. But g of z is equal to 1 by f of z. If g of z is constant, then f of z is also constant, which implies that f of z is a constant function. F of z is a constant function, which is a contradiction to the given statement that every polynomial equation, since n is greater than or equal to 1 and an not equal to 0, mean this function is not a constant function, but we are getting f of z is a constant function, which is a contradiction. F of z is equal to constant function, which is a contradiction, which implies that f of z is equal to 0, which is nothing but a0 plus a1 into plus 1 up to n into z power n as at least one root. The root may be real or complex, which is nothing but exactly every quadratic equation has exactly n roots. The roots may be real or complex. So every polynomial equation f of z is equal to so on a not equal to 0 has at least one root. To prove this theorem, I am using Liouville theorem. F of z is a polynomial with hence it is analytic everywhere in a complex plane. So let us consider another function g of z which is equal to 1 by f of z. Since f of z not equal to 0, then g of z f of z is analytic and g of z is also analytic. And as z tends to infinity, g of z tends to 0, which is nothing but g of z is bounded. So g of z is analytic and g of z is bounded. By using Liouville theorem, any function which is analytic everywhere in a complex plane and bounded in a complex plane, then that function is constant. So g of z is constant. Since g of z is equal to 1 by f of z, hence f of z is also constant. F of z is a constant, which is a contradiction to the given statement that f of z is a polynomial, clearly which is a non-constant function. Hence it's a contradiction. Hence f of z is equal to 0 as at least one root, which is nothing but equivalently f of z is equal to 0 has exactly n roots. Thanks for watching.